Thank you so much. Yeah, good evening, everyone. My name is Kelvin Kaviki Murli. I'm a GIS and remote sensing expert from Kenya. And today we're going to look at the application of GIS in the petroleum industry for oil and gas exploration and production. Each of bracket is also what we call petroleum geology. And it's a very important topic because it's very wide and it's very detailed. And it will provide a lot of insights for you, especially the people in the field of geology or people in the field of GIS. It will bring that combination together and to give you a good platform. So by what we're going to look today, we're going to look at prepare a table of contents and what we're going to cover today. And the first part we're going to cover is GIS technology. That is a brief background of also definition of GIS, briefly what GIS entails. Then the second part is about the application of GIS in petroleum exploration. And the third part that we're going to talk about today is the future trends in the application of GIS in petroleum exploration. And then we also have a conclusion, and then a question and answer session where you'll be able to ask me questions, maybe a place you didn't understand, or maybe you need to be expounded on any issue. And for sure, no doubt, many readers will agree that GIS, particularly in the context of petroleum, is very wide. And very wide, and in terms of development, it's one of those technologies that is hard to get one's arms around at. GIS is very broad. It's very in terms of application, it can be applied in almost every field. Actually, it's every field. And today our focus will be on petroleum and oil exploration and production. So we are going to have the bigger picture of what GIS is, and that's why you see the page is blank, because I want you to imagine how big GIS is. This is something that is not bound, it's beyond compatibility. What do we say? It's beyond human capability. It can be applied everywhere, and that's why the bigger picture of GIS is that it's a very broad scenario. It's a very broad category, a very broad technology that is applicable in every aspect of our lives today. And so the part one, we are going to look at the GIS technology in terms of a brief background and also what GIS entails. And basically, what is GIS? For those that we had a session yesterday, GIS, is it a digital mapping tool? Is it a digital analysis tool? Is it a computer-based visualization system? Is it a modeling tool? These are some of the questions you need to ask yourself. What is this GIS? And once you ask yourself those questions, then I'm going to give you the answers to those questions of what GIS is. So I'm going to give you a definition of GIS, and a definition of GIS is a computer-based system which is capable of assembling. Remember, the key things here is what GIS is capable of. It's capable of assembling, it's capable of storing, it's capable of manipulating and displaying georeference data. So if someone asks you, what are the functions of GIS? The functions of GIS are those that I've stated there: assembling, storing, manipulating, and displaying georeference data. Those are the functions of GIS. Another definition of GIS is that it's a computer-based system for managing geographical data using this data to solve spatial problems. So basically, this is a computer-based. You can't use GIS without a computer. That's why you see in the definition we're starting with, GIS is a computer-based system. So, and remember, a system is not composed of one thing. A system is composed of different parts, and that's why yesterday, because we had a session with yesterday, I gave the components of GIS, because those components now gives you the system that I'm talking about right now. So the next thing is we're going to look at the functions of GIS, or what we call GIS functionality. As you can see from the screen, these are the functions of GIS. This is what GIS can be able to do. And there are 7 key functions of GIS that you need to know, because You go somewhere, someone asks you, who are you? Tell the person, I'm a GIS expert or I'm a GIS and remote sensing student. And they ask you, give me the function of GIS. What can GIS do? So these are the functions of GIS. This is what GIS can be able to do. Number one is acquisition and verification of data. Number two is compilation of data. Number three is storage of data. Number four is updating and changing data. Number five is management and exchange of data. Number six is retrieval and presentation. Number seven is analysis and combination. All these are the functions of GIS. If you're able to understand the function of GIS, then you can be able to apply. And if you cannot be able to know the function of GIS, then you cannot be able to apply. And the next part that we're going to look at is the components of GIS. What is GIS composed of? What makes GIS, and some of the components of GIS, they are here. We're going to look at the 6 components of GIS. As you can see from the graphical representation there, we have the hardware. The hardware composes of the tangible part of the GIS system. The tangible part, we're talking about the computer itself, or the desktop, or using the laptop. And then we have some of the components of the desktop. We have the keyboard, we have the monitor of the screen, we have the mouse, we have the hard disk, we have the RAM. Those are the hardware components of GIS. Then for the software part, these are what enables the system to run. And when we talk about the software, we talk about the QG software, we talk about the ArcGIS software, we talk about NV, we talk about LDAS, we talk about all those software. And then we have number 3 is the data. This is what you run into the computer. This is what you feed. This is the food. This is a food for the computer. This is a food for GIS, the data. Because without the data, you cannot be able to do any functionality of GIS without data. So data, we have the spatial and spatial data, which I'll be discussing in details as we go on with the presentation. And then number 4, we have the users. The users are the people. Me and you, and the expert, that is the user. And then we have the networks. The networks, these are how you apply these GIS. Those are what we call the networks. And the networks you can use, GIS can be used in several networks. You can be used in transport industry, can be used in military, it can be used in urban planning, it can be used in forestry, weather forecasting. All those are what we call the network. The network is the application. And then the approaches now, the final component of GIS is the approaches. The approaches, this is how you manipulate the data you have for GIS. And the approaches, we have what we call supervised and unsupervised classification approaches, of which I'll also be discussing into details as we go on. So you can see from the graphical representation there, we have the GIS as a central component there, and then we have the components of GIS, the hardware, the software, the data, the users, the procedures, and the networks. Then we go to the next thing, and world, you can see how GIS has been used in the world out there. GIS can be used in mapping, it can be used in data storage management, manipulation analysis, presentation, and distribution. This is how GIS works. And for more clarification, you can see the pictorial presentation there. We have how the information, or how GIS information flows. As you can see from the top, this is a sample of obtaining image from the satellite, from the sky, and then being able to manipulate or analyze it to give you a perfect graphical representation on the ground. So you can see the lower part, that's what people want to see, or that's what is represented, but you don't obtain data as it is there. You get data from the sky, from the satellites. We have different types of satellite. We have Landsat satellite, we have Econos, we have Spot. So the various satellites, once you obtain that data, then you're able to manipulate and analyze that data to give a better presentation. Then we're going down to part 2. What is the application of GIS now in petroleum exploration? And we are going to look at the GIS application in petroleum geology. Petroleum exploitation is also called petroleum geology because it gives us the same aspect. That's why you find most of the times I'll be using petroleum geology. So when I say petroleum geology, you understand this is the oil and gas exploration and production. That's what we call petroleum exploration or petroleum geology. So the petroleum is the most important and foundational energy in the world at present. We can't do anything without petroleum. You know, petroleum is a source of the gas. In the modern century, we're using gas in the form of LPG, liquefied petroleum gas, at our homes to cook. We're using petroleum also in form of gas, fuel for vehicles, fuel for ships, fuel for airplanes. So you can see how crucial this petroleum is. We also use petroleum as kerosene for people who can't afford the LPG. So petroleum is very fundamental and it's very, very crucial in our source of energy. And it's also the most capital intensive, which means revenues are large and also the cost of exploring are very large. It has also made headlines for unseen accident and environmental hazards when you're coming to explore the products. Also, the ever-changing dynamics of this industry drives sustained efforts for increased efficiencies and risk mitigation. So the oil and gas industry is driven by an estimated 80% data, which has spatial component. You can see 80% component of oil and gas industry has 80% spatial data component, which means the spatial data component we're talking about is GIS. So you can see the oil and gas industry requires 80% of GIS. That's how crucial GIS is. This is the only industry that harnesses spatial information at every stage of life cycle. How brilliant is that? I love that statement. You see, it's the only industry that uses GIS at every step of the way, which means without GIS, you cannot do exploration, especially in this 21st century. And beginning with opportunity analysis, all the way to exploration, all through to appraisal and production, right up to abandonment phase, GIS is involved all the way. And so companies are beginning to understand the importance of geospatial to maximize ROI. ROI is what we call return on investment. You see, if your ROI is low, then you're not in business, because if your ROI is high, that means your business is making good profit. But if your return on investment is low, that means you're going into losses. And that's why most companies today are incorporating GIS to maximize on return on investment as well as minimizing risk. And I'm going to give you a graphical presentation. I don't know if you can be able to see it very well here, but I'll share the image below so that you can be able to see how GIS has been incorporated at every step, and that's what we're going to discuss below there. So, discovering new sources of petroleum ahead of competition is one of the key ways to stay successful in the petroleum industry. Remember, for you as a miner or a mining company or a mining corporation, for you to be able to stay afloat in this competitive industry of petroleum, you need to have, number one, you need to have adequate oil reserves. And if you don't have adequate oil reserves, then you need to have knowledge or information about new oil reserves. And how do you do that? A GIS system can help you evaluate the potential for oil in promising location. GIS, you can use a spot 8, which is a very, very strong satellite, can be able to spot oil reserves. And if you are good in GIS, that means to say you're very good to be in a better position in terms of competition, because you using GIS can be able to see new oil reserves, then you'll be good in business. Exploration often requires analysis of satellite imagery, digital aerial photomosaic seismic surveys, surface geology studies, subsurface and cross-section interpretation of images, well location, and existing infrastructure information. And how can we be able to gather all that information sufficiently? GIS will give you that platform. It will give you that capability of getting all that information into one hand. You see, and then another thing is GIS can relate these data elements to the location and allows you to overlay, view, and manipulate the data. GIS technology today allows you to manage the spatial components of these everyday petroleum business objects, such as leases, wells, pipelines, and environmental concerns, facility, and retail outlets. You see how GIS is very important. GIS is what we call the backbone of the 21st century business. You can't do without GIS. GIS, you're supposed to incorporate it in every aspect of you. Yeah, so as we go on to look at application of GIS in petroleum, we also look at the oil and gas exploration, collect a large quantity of data. Most of them are based on spatial geographic position. GIS is used to manage, inquiry, analyze, and visualize data. All of these data, figures, and information are managed integrated. Spatial elements can be formed by these spatial data. With GIS, all of these data can be integrated in a platform of a uniform database. GIS is a new way of doing business. That's why it's very, very important for you to understand and have this knowledge of GIS, especially when into oil and gas industry. And another thing I want us to talk about is about the management of GIS, of petroleum exploration. So we're going to look at the management in petroleum exploration by GIS, which includes building a database to manage the data of oil. You need that database for you to maximally explore oil and gas. You need a database. A database is where you store all the information about oil and gas, or any activities, or any mining activities, or any other processing. You need a database, and you can do that using GIS. GIS also can be used to integrate all the data mentioned above into detailed description of information. And then in the management also, you can be able to do a lot of things using GIS. I'm going to give you a graphical representation of what we call a field life cycle. A field life cycle is the process that you follow during the oil and gas exploration and production. And the first step is what you call well planning and acquisition. This is very important, especially for those who yesterday told me that they wanted to know more about the use of GIS in geology and oil and gas exploration. This is where I need you to focus. This is the field life cycle of oil and gas exploration. And GIS is used at every step of this. There are 8 steps, there are 7 steps, or there are 8 steps actually. And all these 8 steps, GIS is used. And the first step in the oil and gas exploration is what we call the well planning. As you can see from the diagram, the first is well planning and acquisition. You need to understand where the well is. Where's the location of this oil and gas? Where is the location of this petroleum, and how I'm going to acquire that? You can use that using GIS. I told you there are Landsat images, or there are satellite images that can help you know the location of these petroleum deposits. And if you're able to get now, that is the first step. Use GIS to identify oil potential areas or location. Then the step number 2 is what we call the seismic planning. Yes, the first step is you've identified oil location. Number 2 is go to do seismic planning. Okay, what are you going to do now? What do you require? That is what we call seismic planning. And you can be able to do that using GIS. GIS can be able to help you to know what materials you require, what equipment you require, and all the variables that you need for exploration. Then the third step is what you call the exploration. Now the mining. How do you mine now? How do you get this petroleum from the deposit? It's using GIS, using the thermal images of spot setting. You can be able to know the exact location of oil deposit. How deep is it, or how deep down is it? And then after getting that information again, you can be able to know what's the component, what is the geological component of the petroleum. How is it between the rocks, or is it between maybe soft rocks or hard rocks? All that is what we call geological information, and we can be able to get that through GIS. The next step is the field operations. Now the field operations is now the real process of getting now that petroleum from the deposit and to get it to the surface. Once it gets to the surface, now we get to the next step, which is called facilities management. Facilities management is now, once you've gotten the petroleum from the ground, you've brought it to the surface. Where are you going to store it now? Where are you going to keep that petroleum? And that's where we come to facilities management. And then the next step is distribution and pipeline management. Yes, you've gotten that oil or that petroleum, you've stored it in tanks or in storage facilities. Then how are you going to distribute the oil? You need pipeline or you need tankers. And you remember, in this 21st century, we are maximizing on return on investment. That's the ROI, which means people or companies or mining companies are opting for pipeline instead of tankers, because number one, tankers are more prone to accident, which is loss of life and loss of the resource itself. And then number two, when using tankers, you not maximize on ROI, because a tanker will take a long time to distribute the petroleum as compared to the pipeline. That's why many companies, many petroleum companies are opting for pipeline. All right. Then the next step is pipeline routing and vehicle racking. Pipeline routing. This is very, very important, because when you bring pipeline, or when you're planning to do pipeline to distribute this petroleum, you need to understand the demographic of the areas that you want to transport the pipeline. Is it hilly? Is it curvy, or is it meandering, or what's the geographic or the demographic characteristics of that area? You need GIS. GIS will give you what we call DEM. DEM is a delineation elevation model. You see, it will be able to give you the structure of that area. So that it will tell you, from here you go straight, then you're able to curve the pipeline to the right or left, and then it will give you that guidance. And that's the use of GIS. Then you have decommissioning. Now this is the final phase of the process of this process. And this final phase, the decommissioning, is now when you now release the petroleum to flow all the way from the source to the end users. And when it gets to the end, now that's why it's able to be refined into several components. So basically, this is the field life cycle of oil and gas exploration and production. These are the 8 steps which you need to understand very, very clearly. But I'm going to expound more as we go down. And then we're going to look at the GIS deployment through each cycle. Now we're going to look deeply now, because I've just given you the summary. I've given you the summary of the field life cycle, and then let me try to expound more so that people can understand more. And this is how it has been expounded. So the first stage, remember we said step 1 is what? Step 1 we said is well planning and acquisition. So the first step is well planning and acquisition. And in this step is what we call basin analysis. Basin analysis is getting to an overview of where you want to explore the petroleum. And this basin analysis, a map of potential hydrocarbon accumulation, that is hydrological modeling. And when you're doing hydrological modeling, which is the subsurface secondary fluid migration, network mapping, flow direction, flow accumulation mapping across dam. Remember, I was explaining to you about a dam, which is give you the demographic of the area. So, and all these steps here, you need GIS. And a very good example, this is the image you can see from the screen. This is a very good representation of that. I don't know if you can be able to see well. Let me try to zoom it a little bit. This is our location, and I was able to prepare this using the ArcGIS to be able to come up with this map. And this is GIS. I basically did it with GIS. These are being the well planning. That means this is a well location where petroleum is mined, and you get that using GIS. And you can be able to get the real-time information or real-time data using Google Earth. So I zoomed in using Google Earth, and then I took a screenshot and then be able to prepare that map. So you can see how powerful GIS is. And then the next thing we're going to look is about the risk analysis, also the acreage analysis, and then we have something else called the prospect analysis. All these, you consider these three during the first stage, which is the well planning. The risk analysis, what are the risks associated with exploring this petroleum? What is the acreage analysis and what is the prospect analysis? So risk analysis, risk segment mapping for each petroleum element. You need to map these petroleum elements. You need to know to have geological maps. You also need to do ground truthing or validating imagery with field surveys. You need to know the true risk associated with exploring these petroleum products. Is it at the risk high? If the risks are high, then you reconsider your project. If the risks are high or the risks are low, if the risks are low, then it means the project is good. Then we look at the acreage analysis, which is the rapid evaluation and gradation of opportunities using multidisciplinary asset data. Basically, acreage analysis is being able to look at the potential. Is the oil deposits sufficient? If the oil deposits aren't sufficient, then it's not effective to explore them. But if they're sufficient, then you can go ahead. And then when you look at the prospect analysis, basically this is about the hydrocarbon reserves of the volume estimation or rust analysis. And this is being able to look at the components of hydrocarbon like shale, right? You know, hydrocarbon, this is what makes the petroleum hydrocarbon deposit. So prospect analysis is being able to get to know about the volume of these deposits. And then the next step we talk about is the seismic planning. That was a step number 2 in the field life cycle. And the seismic planning, we talked about being able to look at the terrain analysis. Terrain, how the terrain of that area, you know, how do you have any map? Do you have any satellite image or spatial analysis to get to know the terrain of that area? Because if the terrain is poor, you cannot be able to access the oil deposits or the petroleum deposits. And during this seismic planning, terrain analysis can be done using maps or can be able to use satellite image. If you cannot be able to get there, you can be able to use satellite images to have the view of that place, how it is, right? And you do that using what we call Google Earth or Landsat image, and that is GIS. Then the third step is what we call exploration. If you can remember, that was the third stage. And in exploration, this is about well planning around multiple drilling constraints, and GIS are used in this pattern. And in well planning, you do what we call optimization workflows, which is the drilling and production. And in drilling, Spatial analysis within GIS for optimized well drilling patterns and efficient configuration. You need to know the structure, how you're going to drill that petroleum, and you do that using GIS. In production, again, GIS allows data integration and visualization of production, volumes, injection rates, and recovery efficiency in near real time. And all this you can be able to do with GIS. I'm giving you a pictorial representation of that. And I don't know if you'll be able to understand, but if you can be able to look, if you can be able to look on the left side, where you can see the left side of the image, so somewhere we've got layers. You can see something called well analysis, production, injection. If you can see that here, let me move. Let me show you with the cursor of my computer. If you can see on the left side, you can see here, there's what we call wells analysis, product injection, wells, structural maps, resources, blocks, and all that. You can see GIS can be able to do all that for you, and then can be able to give you very, very confined and accurate data when you're going to do the exploration. That's how powerful GIS is. You know, it gives you the real-time information, even when you're not on the ground. You just need a computer, and then you need to have that knowledge on how to do it. And then it will give you very, very accurate and real-time data. And then we go to the next step here, which is the next field life cycle, which is about field operation. And GIS supports drilling around surface and geologic constraints, improved field production efficiencies for all reservoirs of basin, and data integration and visualization in real time for production dashboards. All these information, the field operations can be able to be done using GIS. You need to give the command to your computer, which or the GIS system itself, and then it will be able to do all that for you. That's GIS. I love GIS because it's really strong. The next step is facilities management, and you can see facilities management. We are going to look at the 3D GIS. 3D GIS is with field layout, which helps accurate monitoring of associated environmental changes in near real time for HSE, which is the safe health and safety, environment, and emergency response during earthquake. What we're talking about, facilities management, is big GIS because it's computerized, right? Which it can be able to manage activities for you. You know, your work is just to be on the screen, see how work is being done, and it will be able to monitor all that for you. And a perfect example about what we're talking about is, if you can see from the image there, you can be able to see this is like what you obtain from the satellite, and then you're able to analyze and manipulate to a very, very fine end user. We call it end user map, and that is GIS. It can be able to do all that for you. And then the next step is about the distribution and pipeline management. That is how you're able to distribute that petroleum. And least cost path analysis. Least cost path analysis is what we call now pipelining. Like, you need to maximize, number one, you need to maximize on petroleum transportation. That's why I was telling you, like, in the 21st century, people are opting for pipeline instead of trucks, because number one, trucks will take longer time to reach the destination. Number two, trucks cannot be able to transport large volumes of petroleum. Number three, trucks has higher risk in terms of accident, right? And when it comes to pipeline has lower or least risk associated with it. And that's why most companies are opting for pipeline. And for you to do pipelining, you need to understand what we call the least cost path analysis for distribution network, which is a network analysis for environment friendly and cost-effective routes. You need to take shorter routes or cost-effective routes, right? And these are monitored by GIS. GIS can be able to do the DM for you and give you a perfect route. That's why I love GIS. Then the next thing is the next step is pipeline routing and vehicle or fleet tracking. A GIS ecosystem supports tracking of valuable assets. You know, you can you can be able to track the trucks that transport the petroleum. You can be able to track also petroleum in pipeline. That's how strong GIS is. You can be able to monitor what is the volume that is being transported using this pipeline. What's the volumes? You can be able to do that using GIS. And then the last step is decommissioning, and decommissioning is just the final stage where you let everything flow. And you can see from the image, here is a 3D image of an example of oil and refinery production. And you can get a video. I was not able to attach the video here so that you can be able to see how the 8 steps that I've discussed here. You can click to the website link, that is www.s3.com, and you'll be able to get that video on how this petroleum is explored or is being mined from stage 1 to the 8th stage. Very perfect video, but I was not able to, you cannot attach a video in a PDF. That's why I've shared the website link. Click on it, see the video. Very perfect, well detailed, and that will give you a very brilliant concept on how GIS has been applied. And then those are the 8 steps on how GIS has been used in oil and gas exploration and production. And then I decided to give you something on the benefits of GIS in oil and gas. Why are you using GIS? What are the benefits of GIS in oil and gas exploration and production? Why are we using GIS? And I want to give you some of the benefits of using GIS. And number one is it empowers decision making. One benefit of GIS is that it empowers decision making, which accurate or play to enter, how to shorten portfolio workflows, or how to plan optimal pipeline route. All these factors, they help in decision making. Once you have this data at hand, you can be able to make a very good decision, and that's why GIS gives you that empowerment in decision making. Another benefit of GIS is that it supports future action and ongoing exploration activity. It supports. If someone asks you, why are you doing what you're doing? And you can be able to tell them, I'm doing this because of this and that. GIS gives you that confidence, or that momentum, or that capability to support the actions that doing at the moment, and also future actions, by standardizing processes and reducing technical uncertainty. GIS improves exploration efficiency. It improves the efficiency. It makes things work better and smarter, and in a very proactive way. And that's another benefit of GIS. Another benefit of GIS is that it increases efficiencies. Multidisciplinary data integration for risk assessment and uncertainty, better access to cutting wasteful downtime, optimized maintenance schedules, monitoring and analysis of daily fleet movements in real time. All these are monitored using GIS, and the increased efficiency. That's how powerful GIS is. Another advantage of GIS is that it reduces cost. It's a cost-saving tool. It's a very effective tool. An estimate of 10 to 30% cut in operational costs. You see, because it gives you that technical know-how on what you're doing in terms of prevention and management of incidental or accidental costs. That's how GIS helps. Then another benefit of GIS is improved communication. You see, it also helps in record keeping. A huge data loaded in centralized GIS builds a very strong framework for managing data. These are some of the benefits of GIS. I love them because these are the main benefits of GIS because they're very strong and they're very, very important. So I'm going to look now at the final thing I'm going to look about is the usage of GIS in terms of the overview of the uses of GIS in oil and gas industry. We have looked at how GIS is used in the 8 steps from the well planning all the way to decommissioning. And then now I want to give you a brief overview on the uses of GIS in oil and gas industry. And number one is data index maps. GIS helps you, to give you maps. Like if for example, I know where I want to drill or I want to explore this petroleum, right? And I don't have the capital, I don't have the finances. Then, as a GIS expert, you can sit down, make a well-detailed plan or a well-detailed map, then approach these financial corporations or financial corporates and tell them, hey, look at this map, 20 degrees But if you don't believe it, let me show you the real time. You just click into satellite images, be able to show them the location, be able to use Google Earth. That's one emergency response. GIS can be used in emergency response. And how can it be used? GIS is becoming increasingly we have hired that developed a very, very big oil leakage in the ocean. And if they had used GIS, they could have saved that. And the best thing about GIS is that today you can be able to monitor those, even the tiniest oil spill. GIS can be able to pinpoint and pick that. And if you get an oil spill, you respond that immediately. And that's why it reduces accident. So GIS has been used in emergency response. That is very good. And then another use of GIS is that it helps in pipeline monitoring. Yeah, you can be able to monitor the flow of petroleum in pipelines using GIS. You can be able to see how it's flowing very, very effectively and sufficiently. That's the use of GIS. I'm going to give you an image of that. You can see, if you can see from the image, that's the pipeline mapping, monitoring, and integrity management with the GIS. Very, very fantastic. And for you to get such a model, you need GIS because GIS will give you a 3D model, a DDEM model, which will give you a perfect location for pipelining. When you do the pipeline, you don't just put them there because you want to do that, but you need GIS so that you can be able to give the perfect location, the perfect route, the shortest and the most effective route, and all that you can be able to use GIS. That's how beautiful GIS is. And then another use of GIS in oil and gas industry is block ranking. And block ranking is ranking opportunities through quantitative analysis using all the available information required in data integration. GIS provides the perfect environment in which to rapidly evaluate and grade oil and gas licenses and lease block. What we're talking about the block ranking is that it's be able to prioritize. Block ranking is be able to prioritize. Like you've been able to identify 10 oil reserves, right? Remember, you don't just go and mine or just go and explore the petroleum anyhow. You need to do block ranking. which block has the most quantitative petroleum, which block is more rich in petroleum. And if you're able to do block ranking, you start with a block that is has more petroleum. And when you do block ranking, you're able to now be able to mine, because you cannot go and mine or explore a block that has literally petroleum and leave a block that has more petroleum. So when you do block ranking, you start with a block with more petroleum, and then you focus later on which with least petroleum. So another use of GIS is block ranking. As we continue on, yes. And then those are the uses of GIS, the ones I've mentioned before. And then now I'm going to discuss about the part 3. Remember, when I was starting this topic, I said we're going to have 3 parts. Number 1 is about the introduction. Number 2 is about the application of GIS, and then number 3 is the part 3 I said about is about the future trends with the application of GIS in petroleum exploration. In future, how is it going to look like? Is it going to be beautiful, or how is it going to be? So I want to look at the future trends in application of GIS in petroleum exploration. And the future trends, we're going to look at the first two, very important, which is a spatial enabled project management. Remember, currently we are talking about 3D, right? 3D, 3 dimension. In future, we know we're not going to talk about 3D. We're going to talk about 4D, right? 4D will have killed it. 4D will be the best of the best, and all that will be achieved using GIS. Something 4D will give you a spatially enabled project management. You know, with a computer, you can be able to mine everything from step 1 to the last, just using the computer, even without going to the site itself. And that's what we call 4D, a spatially enabled project management. Very, very impressive. The second future trend we're looking about here is what we call immersive environment. Immersive environment is this. I don't know if you can be able to see this image very well, but I will share the PDF with you so that you can be able to look at it very perfectly well. You can see here we're having about the 3D modeling and synthesis. We have data-driven modeling, and then we have expert-controlled modeling. In future, all these 3 will be incorporated into one thing, and it's through GIS. Very fantastic, very, 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 very fine. And that will reduce the cost, and that will make it very effective and very efficient. Then the concept of immersion. What is this concept of immersion that we've talked about here? The concept of immersion is about data integration and collaboration. That is increasing information space from different sources to targeted users. And then we also have increased spatial understanding and enhancement of more natural interaction. Very, very fantastic GIS. And I'm going to show you, start to be able to understand is about in this image here. This is what we call about spatial immersion. Spatial immersion is being able to incorporate to increase the knowledge space. Knowledge space is bringing a lot of information into one pool. We call it a pool of information, and that pool of information is obtained through GIS. You can see we have three dimension here. We have the human machine interface. Then we have the second division, we have the simulation system, and then we have the third, which is the network. So the three dimensions, what we call the 3D, the 3 dimensions are going to be incorporated into one interface using GIS. Very fantastic. And these are some of the pictorial presentation about GIS in terms of weather forecasting and all that, and that we discussed some time back. And then also these are some also another modeling. I'm going to share the links where you can be able to see these videos. You know, it will be very, very fantastic for you to see these videos in terms of using the satellite to locate those oil deposits. You will be able to see that through the links. that I will share with you. GIS is very perfect, and I encourage you all to embrace GIS because GIS is the solution for the 21st century. Without GIS, we will be going backwards instead of going forward. And in conclusion, this is what I want to say is about my conclusion is about three things. Number one, the oil and gas industry has been a comparative latecomer to GIS. However, it is fast emerging as the industry with the highest potential in GIS application through the entire life cycle. You know, initially what this statement means is that before GIS was not used in oil exploration or petroleum exploration, but currently it's the only sector that uses GIS in every stage of its way. Number two, what's more, it enables a seamless integration of the spatial data like UAV, sensors, and the existing computer system within GIS framework. What this statement means is that GIS has the potential of incorporating all those factors into one set pool or one framework, and that's the GIS framework. Number three is that GIS is helping companies compete in the global race to unlock new energy sources and maximize the value of its assets. A mining company that does not use GIS is not in business. Honestly, a company that is using GIS is in the front line. You know, it can be able to, you cannot compete with a company that is using GIS and they're not using GIS. Because number one, a company that is using GIS will have higher potential of new oil deposits when you will not have that potential. That's why we are saying it's helping companies compete in a global race. Yeah. So those are the three conclusions that I have for you today. And that is the end of our discussion today. So thank you so much. I've shared this image to encourage you. This is a very great technology where you can be able to use the Google so to be able to see 3D dimension like from step one for the 8 steps from the oil planning to the commissioning. You can be able to watch like you there, you're using every step of the way. So thank you so much, SkolarGate, for again this opportunity for allowing me to give this lecture. And thank you also for those who have attended this lecture. This is what I had for you today. So this PDF is going to be shared for all of you who have been able to attend this lecture. And I will allow anyone with any question to ask me. And